welcome to the first video on disguised quadratic equations or hidden quadratic equations. Um, disguised, or hidden, disguised or hidden quadratic equations. So this is a new concept to most of you in maths. We've been dealing with quadratic equations for a really long time now, and we said that quadratic equations or quadratic expressions are written in the form of y is equal to ax squared plus bx plus c. This is a quadratic expression, and quadratic equations are written in the form of ax squared plus bx plus c is equal to 0. This is how quadratic equations are written, and this is how quadratic expressions are written. Now, we have another thing that we call disguised quadratic equations or hidden quadratic equations or hidden quadratic expressions, disguised quadratic expressions. So what are they? Some equations are quadratic equations, but in a hidden manner. For example, let's say I give you the equation x to the power 8 minus 6x to the power 4 plus 8 is equal to 0. I give you this equation here, and then I ask you to solve this equation. Just by looking at this, you probably wouldn't be able to solve it. You wouldn't know where to start because it looks a bit scary at first. X to the power 8 minus 6x to the power 4, you see this power of 8 here, you see this power of 4 here, and you get scared and you actually don't know how to solve it. But if I were to tell you that you could say let a equal to x to the power 4, okay, let a equal to x to the power 4. We don't have to say a, we can say b, we can say d, we can say f, g. Anyway, we're just giving this x to the power 4 here a general letter, for example, the letter a. What that means is if a is equal to x to the power 4, then a squared is equal to x to the power 8. If a is equal to x to the power 4, then a squared is equal to x to the power 8. Why is this? A squared is equal to a multiplied by a, which is equal to x to the power 4 multiplied by x to the power 4. This dot here means the multiplication, and the bases are the same, so you add the powers. 4 plus 4 gives you 8, which therefore implies that a squared is equal to x to the power 8, which therefore implies that a squared is equal to x to the power 8. So if we let this x to the power 4 here equal to some arbitrary letter a, or it can be c, d, e, f, g, whatever it is, then the square of that is going to be equal to the square of this. You're squaring both sides. You square a, you have to square this x to the power 4, and you're going to get x to the power 8. So a squared is going to be equal to x to the power 8. Now, why are we doing all this? If we let a equal to x to the power 4, wherever we see x to the power 4, we're going to replace it with a. And wherever we see x to the power 8, we're going to replace it with a squared. Well, what do we have here? In this equation here, we do have an x to the power 8, and we do have an x to the power 4. So wherever in this equation we see an x to the power 4, we're going to replace it with an a. And wherever we see an x to the power 8, we're going to replace it with an a squared. So what does that mean? It means that this equation here is actually going to turn into a squared minus 6a plus 8 is equal to 0. And look what happens. this becomes a quadratic equation. This becomes a quadratic equation because now you have a squared minus 6a plus 8. And you can solve this. You recognize this. This is a quadratic equation. So we've turned this equation here into a quadratic equation. So this equation here, this entire thing here, all along was actually a quadratic equation, but in disguise. In disguise. It was a quadratic equation that was hidden. It was lurking somewhere in the dark. We couldn't find it, we couldn't see it, but now we've brought it out. Now we've actually brought it out. So we've actually brought out a quadratic equation from this entire expression here. So this is what a disguised quadratic equation is. So a disguised quadratic equation is basically an equation that's quadratic, but you can't see it from the get-go, and you have to convert it into a quadratic equation. So how then would we solve this? Well, to solve this, we would then solve this quadratic equation for a. The solutions to this quadratic equation are the solutions for a. So let's actually solve this quadratic equation. Well, this quadratic equation, you can factorize it into a minus 2 and a minus 4 is equal to 0. You can factorize this and you can solve it. So therefore, a is going to be equal to 2 and a is going to be equal to 4. So just solve this quadratic equation normally. Factorize it, you get a minus 2 and a minus 4, and then you get a is equal to 2 and a is equal to 4. But because here we said let a equal to x to the power 4, if a is 2, then what that means is that x to the power 4 is equal to 2, and x to the power 4 is equal to 4. Alright? Because here you said let a equal to x to the power 4. So if a is equal to x to the power 4 and a is 2, then 2 is equal to x to the power 4. So x to the power 4 is equal to 2. And x to the power 4 is equal to 4 because a is equal to 4. And from here, you take the fourth root, both sides, to make x the subject of the formula. And you're going to get x is equal to 1.189 and x is equal to 1.414. And this is one solution, this is another solution. So x is equal to 1.189 and x is equal to 1.414, and you can plug these back into the original expression to see that they confirm the answer. So this would be the solution to this equation. So we've taken this equation here and we've converted it into a quadratic expression, and we've solved it for a, and then we went back to this statement here to say, well, if a is equal to x to the power 4 and a is equal to 2, then 2 is equal to x to the power 4. If a is equal to x to the power 4 and a is 4, then 4 is equal to x to the power 4. And then from there, we solve for x and we get this. So this is what a disguised or hidden quadratic equation is. And we are going to look at two more examples of disguised quadratic equations. Until next time.